Light and the shape of spacetime. A thought experiment. Gravity without a graviton, and photon energy as penetration depth into a fractal spacetime substrate. Preface and a disclaimer. What follows is a speculative thought experiment. It is not a theory. It makes no quantitative predictions. It contains no new mathematics, and it does not claim to overturn any established physics. It is an attempt to organize several well-known puzzles: the graviton problem, the interpretation of virtual particles, the energy dependence of photon interactions, and the origin of mass under a single geometric intuition, and then to trace where that intuition touches real, published research. Everything in Part 1 is interpretation and analogy. Part 2 identifies the existing theories each idea is adjacent to or derived from, along with the observational constraints that any serious version of this picture would have to survive. The work referenced in Part 2 is real, published physics. The synthesis connecting it is the conjecture. A full reference list accompanies this recording. Part 1. The picture. The core idea, in one paragraph. Imagine that spacetime is not a smooth, empty stage, and not a simple grid of pixels either, but a deeply folded, self-similar structure, a fractal-like topology wrapped into itself at every scale. Everything we call a particle, a force, or a virtual particle is not a thing sitting on this structure. It is a feature of the structure itself, a fold, a channel, a well, a ripple. Gravity is not carried by a particle at all. It is simply the large-scale shape of the substrate. And light, the one truly massless traveler, interacts with this substrate in a way that depends entirely on its energy. Low-energy light glides across the surface. High-energy light burrows into the folds, where it can finally touch the buried potentials we call matter. 1. Getting rid of the graviton. Physics describes 3 of the 4 fundamental forces the same way. Particles interact by exchanging force-carrier bosons. Photons carry electromagnetism. W and Z bosons carry the weak force. Gluons carry the strong force. When physicists tried to quantize gravity, they naturally reached for the same tool and proposed the graviton, a massless particle that would carry gravity. It has never been detected. Worse, the mathematics breaks down. Gravity resists being described as particles exchanged on a fixed background, because gravity is the background. This thought experiment takes that hint seriously. In this picture, gravity is not mediated. Gravity is shape. If spacetime is a structured substrate, then what we experience as gravitational attraction is just the way the substrate curves and flows around concentrations of locked-in energy. No messenger particle is needed, for the same reason a valley does not need a messenger to tell a river which way to flow. The valley is the message. The graviton was always a patch, an attempt to force gravity into the same particle exchange framework as the other forces. If geometry is fundamental, the patch is unnecessary. The curvature does the whole job. 2. The substrate, not pixels, but folds. The usual quantized space-time picture imagines space as grainy, made of discrete chunks at the Planck scale about 10 to the minus 35 meters. That is a start, but it may be too crude. A grid of pixels is still fundamentally simple. Instead, picture a fractal topology, a structure that is self-similar across scales, folded and wrapped into itself. Zoom in, and you find more structure. Zoom in again, and you find echoes of the same patterns recursively. The substrate is not a floor. It is more like a coastline, or a lung, or the branching of a river delta. Surface area and internal complexity hiding at every level of magnification. Crucially, this structure has interior. It has nooks, crannies, channels, and wells. Some regions of it are shallow and smooth. Some are deep and intricately folded. Those deep regions are where the interesting physics lives. 3. What particles are in this picture? In this framework, a massive particle, an electron, say, or a quark, is not an object placed into space-time. It is a stable knot in the substrate, an excitation locked into one of the deep folds of the topology, a self-sustaining pattern trapped in a potential well that the geometry itself provides. This immediately offers a reading of something odd about the standard model. Why do particles come with fixed specific masses? And why can they only be created above specific energy thresholds? In this picture, the answer is geometric. The topology of the substrate contains a landscape of wells at different depths. Each stable well shape corresponds to a particle species. The depth of the well corresponds to the particle's mass. You cannot create a particle until you can deliver energy down to its depth. The Higgs field's famous non-zero ground state, the ever-present background value that gives particles mass, becomes, in this language, the ground state shape of the substrate itself. Mass is not a substance. Mass is how deeply a pattern is anchored into the geometry, and since gravity responds to mass, gravity responds to anchoring depth, which is consistent because gravity here is nothing but the substrate's large-scale shape, responding to its own deep deformations. 4. Light, the surface glider. Now the centerpiece. The photon is unique. It is massless. It does not couple to the Higgs field. In our language, it is not anchored into the substrate at all. It is the one excitation that travels purely along the geometry, rather than being embedded within it. So picture the photon as a ripple, gliding on the surface of the fractal substrate, always moving at the universal speed limit, never sinking in, unless it has the energy to reach inward. Here is where frequency enters. A photon's energy is set by its frequency. Energy equals Planck's constant times frequency. And frequency, in this picture, is the fineness of the ripple. Low-energy light. Radio waves, microwaves. A long, slow, coarse undulation. Far too broad to feel the fine folds of the topology. It skims the surface, passing through matter almost untouched, which is exactly what we observe. Radio waves sail through walls, through bodies, through the atmosphere, interacting with almost nothing. High-energy light, X-rays, gamma rays, a tight, rapid, fine oscillation. Its wavelength approaches the scale of the substrate's inner structure so it can penetrate into the nooks and crannies, down into the folded interior where the potential wells live. This is why high-energy photons are destructive. They ionize atoms, shatter molecules, and knock electrons free. They are not merely stronger, they are reaching deeper into the geometry, where the anchored patterns we call matter actually reside. And at the extreme threshold, something remarkable happens. It is real, observed physics. A photon with enough energy, about 1.022 mega-electron volts near a nucleus, stops being light and becomes matter. It converts into an electron-positron pair. In this picture, that is the moment the ripple penetrates all the way down into a pair of vacant wells and gets caught. The surface glider dives deep enough to become two anchored knots. Light literally becomes mass by sinking into the topology. The threshold structure of particle physics, the fact that you need specific energies to make specific particles, is, in this view, simply a map of the substrate's interior depths. 5. The reverse direction. How matter makes light. The picture must work both ways, so run the film backwards. When an electron and a positron meet and annihilate, two anchored knots at matching depths unlock each other. The energy that was holding those patterns down in their wells is released, and it has to go somewhere. It surfaces. It becomes photons, ripples, ejected back onto the surface of the substrate, gliding away at light speed. The two processes are mirror images through the topology. In pair production, a surface ripple dives into the folds and becomes two anchored patterns. Light becomes matter. In annihilation, two anchored patterns collapse their wells and eject a ripple out of the folds. Matter becomes light. Every emission of light, from a candle flame to a gamma ray burst, is in this language some anchored pattern in the substrate shifting to a shallower configuration and shedding the depth difference as surface ripples. Every absorption is the reverse. The photon is the universal currency of exchange between the surface and the interior of the geometry. 6. Virtual particles. flow channels, not ghosts. Standard physics is haunted by virtual particles, entities that appear in every calculation, mediate every force, and yet can never be observed. They exist for infinitesimal moments, borrow energy from nothing, and vanish. Physicists use them constantly, while quietly acknowledging they may be nothing but mathematical bookkeeping. This picture offers a cleaner interpretation. Virtual particles are not particles at all. They are the flow channels of the substrate. Between the deep wells, the folded topology contains connecting passages, grooves and channels through which influence propagates from one anchored pattern to another. When two electrons repel, no ghost photon flies between them. Rather, their two anchored patterns are connected through the surface channels of the geometry, and the deformation of one propagates along those channels to the other. The virtual photon in the equations is a description of the channel, not a report of a particle. This reading fits their strange properties. Why can we never observe them? Because they are not objects, they are the plumbing. Why do they seem to borrow energy? Because a channel can transiently deform in ways a stable pattern cannot persist in. Why do they govern all interactions? Because all interaction is transmission through the substrate's connective structure. There is no other way for anything to touch anything. Virtual particles are thus an emergent property of the fractal geometry, the shadows that its internal channels cast onto our particle-based mathematics. 7. Extreme environments, when the substrate changes shape. Here is where the picture makes a genuinely distinctive claim. A fractal is self-similar, but self-similar does not mean rigid. The same recursive pattern can be stretched, compressed, or deformed while keeping its character. So suppose the substrate's topology, while self-similar everywhere, is inherently shaped differently in extreme environments. Near a neutron star, inside a supernova, in the first instance after the Big Bang. In regions of colossal energy density, the folds compress, the wells shift, and the channels between them widen or realign. This immediately suggests a reading of something we actually observe. Different interactions happen more readily in extreme environments. In the early universe, exotic heavy particles were produced constantly because the substrate's hot, compressed shape held its deep wells open and accessible. As the universe cooled and the topology relaxed into its ground state shape, those deep channels effectively sealed, and the heavy particles could no longer be casually made. Electroweak unification finds a natural reading here as well. Above roughly 100 giga-electron volts, the substrate's shape no longer distinguishes the channels we call electromagnetic from those we call weak. They are the same channels. The distinction between forces is a feature of the relaxed, cold ground state shape, not a fundamental division. The Higgs field switching on as the universe cooled is, in this language, the substrate settling into its ground state shape. The configuration whose landscape of wells defines the particle masses we know. The ground state of the Higgs field, the fixed table of particle masses, and the apparent separateness of the forces are all portraits of one thing, the relaxed shape of the substrate at low energy. Change the environment enough, and the portrait changes. 8. Taking it to the extremes. Every thought experiment deserves to be pushed until it breaks or blooms. Here are both directions. First, the low-energy extreme. The frozen ocean. Imagine a universe emptied out, the far future of cosmic expansion, cold and dilute, containing almost nothing but ultra-long wavelength photons, stretched by billions of years of expansion. These photons are the ultimate surface gliders. Their wavelengths are so vast that the substrate's interior is utterly invisible to them. They cannot penetrate, cannot interact, cannot ionize, cannot create. To them, space-time is effectively smooth, a perfect, featureless, frictionless ocean surface. All the fractal richness beneath, the wells, the folds, the channels, still exists, but it is completely inaccessible. This suggests a striking thought. Smoothness is not a property of space-time. Smoothness is a property of low energy. The smooth, continuous spacetime of Einstein's relativity is what the substrate looks like to any probe too coarse to feel its folds. General relativity is the surface view. The heat death of the universe is a world reduced to pure surface. Geometry, with all its depth intact but permanently unread. A library sealed shut, with the last reader gone. Now the high-energy extreme. The ripple becomes the sea. Go the other way. Keep raising a photon's energy, through gamma rays and beyond, up toward the Planck energy, about 10 to the 19 giga-electron-volts. Its oscillation grows ever finer, until its wavelength approaches the scale of the substrate's own deepest structure. At that point, the distinction between the ripple and the sea collapses. A photon whose wavelength equals the fundamental fold scale is no longer on the geometry. It is indistinguishable from the geometry. Its energy density is enough to deform the very folds it travels through. In standard physics, this is exactly the regime where a photon's energy would curl it into a black hole. In this language, the surface glider finally digs so deep that it becomes a permanent deformation of the substrate itself, pure trapped shape, which is to say, pure gravity. This gives the picture a satisfying closure. At the lowest extreme, light decouples from geometry entirely, and spacetime looks perfectly smooth. At the highest extreme, light merges into geometry, and spacetime looks like nothing but shape. Light and spacetime are not two different things. A photon is the substrate's own geometry, momentarily traveling. Energy is simply the depth of the conversation between them. And then the environmental extremes. Between those limits, the shape of the substrate sets the local rules. In deep gravity wells, near black hole horizons, the topology is stretched and strained. Channel structures deform, and interactions that are impossible in flat space, such as the pair splitting we call Hawking radiation, become natural because the strained shape holds wells open at the surface itself. In the primordial universe, the substrate had not yet relaxed. All channels ran hot and open, all wells were accessible, all forces were one plumbing system. Cooling was not a change in the laws of physics. It was the substrate folding itself into the shape whose surface-level portrait is the laws of physics we know. 9. What this picture buys us. To summarize what the single assumption, that spacetime is a self-similar folded topology and everything else is its features, accounts for in one stroke. 1. Gravity without a graviton. Curvature is the interaction. No messenger is needed. 2. Why mass comes in fixed values. Masses are the depths of the substrate's stable wells. 3. Why light interacts more at higher energy. Finer ripples penetrate deeper folds. 4. Pair production and annihilation as mirror processes. Diving into wells versus surfacing out of them. 5. Virtual particles demystified. They are the substrate's connective channels, emergent and unobservable by nature. 6. Why extreme environments change the rules. The self-similar shape deforms, reopening channels and wells. 7. Why spacetime looks smooth. Smoothness is the low-energy surface view, not the underlying truth. 8. A natural ceiling. At Planck energies, light and geometry become the same thing. Part 2. Connections to existing physics. This section maps each element of the picture onto real published research, and it states honestly where the picture is merely reinterpreting standard results, where it borrows from active research programs, and where it faces hard observational constraints. To repeat the disclaimer, nothing here is original mathematics. The referenced work is real. The synthesis is the speculation. 10. The graviton problem in the literature. Perturbative quantization of general relativity treats the graviton as a massless spin-2 field on a fixed background. This program fails as a fundamental theory because gravity is perturbatively non-renormalizable. The coupling constant has negative mass dimension, so the loop expansion generates an infinite tower of divergences. This was established by 't Hooft and Veltman, and later by Goroff and Sagnotti. The split into background plus fluctuation also violates the background independence that defines general relativity. The strategy of treating geometry itself as fundamental, with all dynamics as features of that geometry, is not new. It is Wheeler's geometrodynamics program. Mass without mass, charge without charge. What this thought experiment adds is one organizing principle, that energy measures depth of coupling into a self-similar interior structure, and that single principle is asked to organize photon phenomenology, mass thresholds, virtual processes, and environmental dependence simultaneously. 11. Support for fractality, dimensional reduction. The picture's core structural assumption that spacetime behaves like a scale-dependent, effectively fractal object has striking support from an unexpected direction. The most robust cross-program result in quantum gravity of the past 2 decades is dimensional reduction. The spectral dimension of spacetime flows from 4 at large scales to approximately 2 near the Planck scale. This was found independently in several unrelated approaches, in causal dynamical triangulations by Ambjørn, Jurkiewicz, and Loll, in asymptotic safety by Lauscher and Reuter, in Hořava gravity, and related behavior appears in causal set theory and loop quantum gravity. Carlip's review is the single best entry point to this literature. Independently of quantum gravity, 2 programs take fractality as the starting axiom. Scale relativity, developed by Nottale, posits fundamentally fractal, non-differentiable spacetime and derives Schrödinger-like dynamics from geodesics on it. This is a minority program with contested derivations, but it is the most direct precedent for the idea of quantum behavior as a shadow of fractal geometry. Multifractional spacetimes, developed by Calcagni, build field theory on spacetimes with scale-dependent dimension with explicit modified propagators. This is where the mathematics of particles on a fractal substrate partially already exists. Finally, the picture's self-similar structure, differently shaped at different scales, is structurally the renormalization group made geometric. Wilsonian renormalization describes physics as a self-similar flow across scales. Asymptotic safety is the existing program closest to reading that flow as literal geometry. Near its ultraviolet fixed point, spacetime is effectively fractal. 12. Gravity without a graviton in the literature. The claim that gravity is shape, not exchange, contacts a mature body of work. Sakharov's induced gravity, the Einstein-Hilbert action emerges as an effective elasticity of the vacuum. Jacobson's thermodynamic derivation, Einstein's equations derived from the Clausius relation, applied to local horizons. If the field equations are an equation of state, then seeking gravitons may be as misguided as quantizing sound waves in air to find fundamental phonon molecules. Verlinde's entropic gravity. Gravity as an entropic force arising from information gradients. And analog gravity, reviewed by Barcelo, Liberati, and Visser, effective curved geometry, horizons, and Hawking-like radiation demonstrably emerge in condensed matter systems with no fundamental graviton. This is proof of concept that geometry without a graviton is physically coherent. Now, the hard constraint. Gravitational waves behave exactly as linearized spin 2 perturbations propagating at the speed of light to within about 1 part in 10 to the 15. That is the GW170817 multi-messenger observation. So, no fundamental graviton is viable. No effective spin 2 wave sector is falsified. Any substrate must support surface waves with exactly spin 2 character at accessible energies. 13. Particles as topology. Mass as depth. Precedents for the idea that particles are geometric features. Wheeler's geons, self-gravitating field configurations, as mass without mass. Topological solitons. Skyrmian's model baryons as topological knots in a field. 't Hooft-Polyakov monopoles show particle-like excitations with quantized properties arising as topology. And the work of Bilson-Thompson, Markopoulou, and Smolin on standard model particles as braided states of spin network ribbons in loop quantum gravity. This is the closest existing proposal to the idea that particles are knots in quantized geometry. The reading of the Higgs vacuum expectation value, about 246 giga-electron-volts, as the relaxed ground state shape of the substrate, is an ontological reinterpretation, not a modification of standard electroweak theory. Finite temperature field theory already describes the vacuum expectation value as temperature-dependent, switching on as the universe cools below roughly 160 giga-electron-volts. The picture restates the electroweak phase transition as geometric relaxation, and an open problem. The flavor puzzle. A geometric theory of mass is only compelling if the well-depth spectrum, meaning the Fermion mass hierarchy and the mixing matrices, becomes calculable. Nothing in the current literature achieves this, and nothing in this thought experiment does either. It is the natural target. 14. Photon energy and penetration, standard physics, and constraints. The energy dependence of photon-matter interaction is established physics, organized by cross-section regimes. Photoelectric absorption at low energy, Compton scattering at intermediate energies, pair production above the 1.022 mega-electron-volt threshold in a nuclear field, 2 photon pair production predicted by Bright and Wheeler and observed in quasi-real form by the STAR collaboration, and Schwinger pair production from strong fields. The thought experiment reinterprets this latter as a depth map. That reinterpretation is interpretively economical, but it is predictively empty until it modifies at least one number. If photons coupled to substrate microstructure in an energy-dependent way, the generic consequence would be a modified dispersion relation, with Planck-suppressed corrections. This is the domain of doubly special relativity and of rainbow gravity, in which the effective metric itself is energy-dependent. Rainbow gravity is the closest formalized statement of this picture's central mechanism. And now, the hard constraint. And it is severe. Fermi L8 observations of the gamma-ray burst GRB 090510, with subsequent magic, Hess, and lasso analyses, bound any linear order energy dependence of photon speed to beyond the Planck scale. Photon speed is energy independent to extraordinary precision over billions of light-years. Therefore, in any serious version of this picture, penetration depth must govern interaction coupling, cross-sections, channel access, while leaving propagation speed exactly at the speed of light. The substrate must be Lorentz invariant in its wave sector, with structure appearing only in the interaction sector. Quadratic order modifications remain far less constrained. That is the surviving parameter space. The high-energy extreme also has a standard physics anchor. Trans-Planckian photon collisions are generically expected to produce black holes, since the energy's Schwarzschild radius approaches its wavelength. Light of sufficient energy does become pure geometry in the standard expectation as well. And the low-energy extreme, space-time as effectively smooth for infrared probes, is simply the statement that general relativity is the infrared limit, which is consistent with the effective field theory treatment of gravity. 15. Virtual particles. Interpretation in the literature. Virtual particles are internal lines of Feynman diagrams, terms in a perturbative expansion, off-shell and unobservable by construction. Their interpretive status is genuinely contested. Notably, non-perturbative formulations, such as lattice quantum chromodynamics, compute the same physics with no virtual particles at all, which is strong evidence that they are representation-dependent rather than fundamental. The pictures claim that they are emergent features of connective structure is therefore not radical. The radical part is proposing what that structure is. The reinterpretation of internal lines as persistent connective topology aligns with several serious programs. Wheeler's quantum foam, Planck scale topology fluctuation, including transient wormhole structure. The ER equals EPR conjecture from Maldacena and Susskind. entanglement as geometric connection, and emergent spacetime from entanglement. Van Ramsdonk, building up spacetime with quantum entanglement, the Ryu-Takayanagi correspondence between entanglement entropy and geometry, and Swingle's work on entanglement renormalization and holography, where the Mera tensor network, an explicitly hierarchical and self-similar structure, generates emergent geometry. That last one is the deepest available contact point. In holography-adjacent research, geometry literally is a self-similar network whose connectivity encodes interactions, a rigorous cousin of the claim that virtual particles are the plumbing of a fractal substrate. 16. Environmental deformation in the literature. The claim that extreme environments reshape the substrate, altering which processes proceed readily, has standard analogues that the picture would reinterpret geometrically. Symmetry restoration above the electroweak temperature in finite temperature field theory, Hawking radiation as horizon-modified vacuum structure, and the Unruh effect in which acceleration alone changes which particles an observer detects, already demonstrating that particle content is a property of the observer's relation to the geometry rather than an absolute inventory. Quantum electrodynamics in supercritical fields shows vacuum structure literally reorganizing in extreme environments. 17. What any serious version would have to do. For this picture to graduate from interpretation to theory, it would need to do 5 things. 1. Survive the Lorentz constraints. Implement energy-dependent coupling with exactly energy-independent propagation speed, most plausibly through modified interaction vertices with standard dispersion, or within the surviving quadratic order parameter space. 2. Predict a cross-section anomaly. Some regime, near Schwinger limit laser experiments say, or in ultra-high energy photon astronomy, where substrate penetration deviates measurably from quantum electrodynamics. 3. Derive at least one mass ratio from well-depth geometry. The flavor puzzle is the acid test of the claim that mass equals anchoring depth. 4. Recover the spin. 2 gravitational wave sector exactly as demanded by the neutron-star merger observation. 5. Reduce to general relativity plus the standard model in the appropriate limits per standard effective field theory logic. 18. Closing caveats. To state it one final time, plainly, this is a thought experiment. It proposes no new equations. It makes no quantitative predictions. And it has not been peer-reviewed. It is a synthesis of intuitions, deliberately organized so that each intuition points at real research. Dimensional reduction results supply the fractality. Jacobson, Verlinde, and analog gravity supply graviton-free gravitation. Soliton and braided geometry models supply particles as topology. Rainbow gravity supplies energy-dependent geometry. And tensor network holography supplies rigorously constructed self-similar geometry, whose connectivity encodes interaction. The original contribution, if there is one, is the single organizing principle, that photon energy measures depth of coupling into a self-similar spacetime interior, and the burden on that principle is heavy. It must produce numbers, and it must do so without disturbing the observed exact energy independence of the speed of light. The surface is smooth only because we skim it. The depth, if it is there, was always there, folded and waiting. Every gamma ray is a question asked of it, and every particle an answer that stayed.